All right, so for number 39, this is going to be a triangular prism because the only two faces here that are parallel and congruent to each other are the two triangles. So even though this isn't sitting flat on the base, this is a triangular prism, and these are the two bases here, these triangles I kind of colored in here. Now, your surface area of a prism is the perimeter of the base times the height plus 2 times the area of the base. Now, because I'm missing the third side in this triangle here, to find the perimeter of the base, I'm going to have to do a Pythagorean theorem real quick here. So I'm going to call this x. I'll have 8 squared plus 15 squared equals x squared. So on my computer, or sorry, my calculator, 8 squared plus 15 squared is going to give us 289, and then I'm going to take the square root of that. So x, that missing side, is going to be 17. All right, so my perimeter of the base, 8 plus 15 plus 17, which is going to give us 40. Now, your height is the distance between the two bases. The distance between those two triangles is 36. The area of the base is the area of that triangle I have shaded. So 1/2. Now, the base segment in the triangle would be 15. The height of the triangle would be 8. So 1/2 times 15 times 8, we're going to get 60. So I'm going to take and plug those three values, the perimeter of the base, the height, and the area of the base, into my surface area formula here. So right here, perimeter 40, height 36. That will give you the area of all the rectangles in the diagram that connect the two triangles. And then 2 times my area of the base, which is 60. So 40 times 36. And then we're going to add to that 2 times 60, which will give me a total surface area 1,560 meters squared. For number 40, we're going to reflect this figure over the x-axis, which is this line right here. So for t, it's 1 spot away, so t prime 1 spot away on the other side, r 1 spot away, so r prime 1 spot away on the other side. S, we got 1, 2, 3, 4 to get there, so 1, 2, 3, 4 to get down here. That's S prime. And so the coordinates there, T prime, -2, -1. S prime is -4, -4. And R prime is -4, -1. All right, this is a square. So we're going to label this point P. Now, to go over this distance would be the same as going over this distance for the point up here, because these are going to match up with each other. So the x-coordinate should be -b. And then in terms of the height, you're not going up or down. It's right on the axis, so that should just be 0. So the coordinates of that point, -b, 0. All right, this is a formula on the formula sheet. This is 1/2 the difference of these two arcs. If you have an outside angle that we want, which is A here, you're going to do the difference of the two arcs. Make sure you put the larger number first, or you'll end up with a negative, which wouldn't make sense for an angle measure. So I'm going to do 1/2 times 101 minus 68, which is going to give me an angle measure of 16.5 degrees. Okay. Similarity ratio of prism with volume 128 to prism with volume 250. Okay, so these are the two volumes. The first thing I'm just going to do really quick here is reduce this fraction if I can. So 128 over 250, reduce that is, I'm not doing anything besides reducing this fraction. Both of these numbers are divisible by 2. Now, in terms of your ratios for the figure, that would be your a cubed over b cubed. So we want the similarity ratio. The similarity ratio is just a over b. So this is volume, that's a cubed over b cubed. So what I want to do here is, to get a over b, I'm going to take a cube root. So cube root everything. The cube root of 64 is 4. The cube root of 125 is 5. So that would be my similarity ratio, would be 4/5. Another way you can write that is 4:5. All right, equilateral triangle. That means all the sides are the same. Also means all the angles are the same. So I'm going to drop a height here. This, I didn't draw this very well, but these would both be 60-degree angles. The sides are 8. So when I drop the height there, that's going to split that exactly in half into 4 and 4. The height of the triangle here for 30, 60, 90 should be your short leg, which is 4 times the square root of 3, so 4 radical 3. So the base of the triangle would be 8. The height of the triangle would be 4 radical 3. Area, 1/2 base times the height. We're going to leave this in radical form. So I'm just going to do half times 8 times 4. So we're going to get 16 times the square root of 3, and this guy would be square inches. So inches squared for your answer there. For number 4 to 5, find the values of A and B. All right, now, just for B, real quickly, these two angles form a straight line. So all I have to do for B is 180 minus 44, because we know any straight line adds up to 180, so that's 136. Now, the inside figure here, quadrilateral, so I know the inside angles add up to 360. The other thing you have marked here, this is a kite, and these two angles right here are going to be congruent to each other. So I know a four-sided figure adds up to 360. I'm going to subtract this 90-degree angle right here. I'm going to subtract the 44 right there. So I'm going to do 360 minus 90 minus 44. And if I do that, I get 226. Now we're going to split that evenly between those two angles there in the diagram since we have a kite. So if I cut that in half, this is 113, this is 113. So 113 would be my answer. 46, right triangle, this is the hypotenuse, and this is adjacent to that 26-degree angle. So adjacent hypotenuse, I'm going to use cosine, and that should be 16 over x. Now, if you remember, the variables in the bottom, these are going to trade places. So I'm going to do 16 divided by cosine 26. So that's going to give me, to the nearest tenth, 17.8. For 47 up here, volume of a cylinder, this on your formula sheet, pi r squared times the height. So for this guy, we've got 8 squared times 12. If I want to leave it in terms of pi, what I'm going to do on my calculator is 8 squared times 12. And we'll just write a pi next to the answer. That's 768 pi, and this would be inches cubed since we're talking about volume. Okay, now tangent ratios. You do not have to find an angle measure or anything like that there, like that here, excuse me. You're just going to set up a ratio. Ratio is the fancy word for fraction. All right, so I'm going to focus on B real quick. If I'm doing the tangent of angle B, the opposite would be 20, the adjacent would be 21 in relationship to that angle. That's literally all you have to do. You just set up the ratio. You're not solving anything, you're not finding the angle measure. Now if I switch over to focus on angle C, those two things change. Now the opposite is going to be the 21 and the adjacent is going to be the 20. That's all you have to do is just set up the ratios. For 49, what you want to do here, I'm going to make my radius is 18. Any radius I draw, it just connects the center to a point on the circle is the same. So I'm just going to move the radius over here and I'm going to connect this up to make a little right triangle. Now, because I have this perpendicular here, I know that that's a chord. If it touches a radius, it splits it into two equal pieces. So this 24 here is going to become 12 and 12 on either side of that little segment that comes out of the center. So really all you're doing here is solving for x by using the Pythagorean theorem because we have a little right triangle. So x squared plus 12 squared equals 18 squared. So what I'm going to do on my calculator here is 18 squared minus 12 squared, which is going to give me 180. And we have to write this in simplest radical form. So you can do a factor tree. I'm going to just Find the biggest perfect square that divides into 180. That's the same thing as 36 times 5. So to pull out my perfect square here, square root of 36 is 6. 5 stays under the square root. My answer should be 6 roots of 5. For number 5, lateral area of, this is a pyramid here, what we're going to do, it's 1/2 the perimeter of the base times the slant height. You don't need to find the area of the base here. This is a hexagon, regular hexagonal prism, or sorry, pyramid. Perimeter, let's see here. Base edges of 8, so that's not in the diagram. So each one of the sides around the hexagon are 8. So 8 times 6 for my perimeter of the base would be 48. Now, this question actually gives you more than you need, so they're trying to get you make sure that you know which one of the heights that you need to use for the surface area. The height is used for volume, the slant height is used for surface area. So slant height is 13, you're not even going to use the 11. So this should be 1/2 times 48 times 13. It's just the area of each of the triangles that are in the diagram there. It doesn't include the hexagon. Lateral area does not include the base. So if you multiply this out, the lateral area here, 312 area, so centimeters squared. Okay, after this point, we start to repeat questions. So we've done questions like this before, but we've tried to put a couple extras in here that we thought were a little harder. So this little triangle, 30, 60, 90, this is 4. This would be the short leg right up here, which would be 2, and this would be 2 radical 3. So this little 30, 60, 90 triangle here. If the whole base across the top is 7, we're going to 2 here. That means the rest of it would be 5. So this is 5. So for your trapezoid, 1/2 the height, base 1 plus base 2. The height is going to be that 2 roots of 3. One of the bases is 7, the other base is 5. So I'm just going to, 1/2 times 2 is just 1, and we're multiplying that by 12. So 1 root of 3 times 12, we can multiply the 1 and the 12 together to get our area in radical form. 12 roots of 3, and this would be feet squared for area. Dropping a height here, we're going to find volume. So I need this height. Across here 60, so this would be 30. Area of the base is a square, so the area of the base is just going to be 60 times 60, which will give us 3,600. The only other thing I need is the height. We're going to need the Pythagorean Theorem to do that. So the height squared plus 30 squared would be our slant height, which is 34 squared. So I'm going to do 34 squared minus 30 squared. We're going to get h squared equals 256. So the height here is 16. Now your volume of a pyramid, 1/3 area of the base times the height. So 1/3 times 3,600 times 16. Or you can do area of the base times the height, divide by 3, that'll give you the same answer, 19,200 inches squared here. And I'm going to try and get one more in. You always want to connect the vector to the x-axis if you're trying to find components here. This is 38 degrees, that is outside the triangle, so I'm going to get inside the triangle here. This is 52. Remember, the placement of the vector here, you're going to have to add negatives in front of your answer. Now, 52-degree angle, the y is opposite that angle, the x is adjacent, the hypotenuse is the 32. So to find the x-coordinate of this point, how far am I going over? I'm going to do cosine 52 equals x over the hypotenuse, which is 32. To find your y, that's how far you're going down. You're going to do sine of 52 because you got opposite in y and hypotenuse in the 32. Now for both of these, I'm just going to quick tack on a negative as I do this in the answer. Sorry, it's a little dark in here. So we're going to do 32 times cosine 52. That's 19.7. So I'm just going to put a negative in front of that because of the placement on in the quadrant 3. The other thing I'm going to do to get y, I'm going to do 32 times the sine of 52, and rounded to the nearest tenth is 25.2. So I'm going to put a negative in front of it because of where I've placed on the graph here.